Okay, some of you have said you're having a little trouble with the investigation building a circuit lab, so I was going to just do it here really quickly, so in the phet, so that you could kind of see what's going on. The first part just asks about how do we make a circuit, what's the basic things that we need to have a circuit. You need to have a battery or some other source of electrons or electricity. You need to have conductors. So usually we use wires for that. And we need to have a load, and in this case, for this lab, we're going to use, so a load is anything that's using the electrons. And so that would be our light bulb. But it could be a bell, could be a blender, could be any number of things. So bare minimum you need is a source of electrons, a conductor, a load, and it needs to be a complete circle. Notice if this was open, it didn't work. Okay? It has to be complete. Usually, we also add in a switch, which allows us to control the flow of electrons. Electrons are always going around in one direction, and I think we looked here, they come out of the negative and come back around to the positive. So we looked that up. Okay. So that'll help you answer the first few questions. I'm going to, in the phet, if you're using it and trying this yourself because it's kind of cool, you click this little button right here and it turns it over to the symbols, which then you can just take a screenshot of. I'm going to open up this, take a screenshot of that, and you can take a screenshot of the screen right now, and you can paste that in for your answer for number 3, where it says use the symbols, which are these symbols over here, to draw this. Okay, so that's 1 through 3. How do you know you have a complete circuit? We know we have a complete circuit because when we're over on this one, the light bulb lights up and we can see the electrons moving. If this was really at our desk with equipment, we can't see the electrons moving, so the only evidence we would have is that it's lighting up. List 3 reasons why the light might not go on when you close the switch. Because there could be a bad connection, like we might have done something, put this like this. It could be a bad connection. The wire itself could have a bad spot in it. The light bulb could be broken. The electrons actually have to flow through a little wire inside the light bulb. So if that wire is broken, it won't work. Battery could be dead. There's lots of different reasons. So that'll help you answer the conclusion questions. It says, with your light on and your switch closed, take another wire, I'm looking at number 4, and connect the clips. So we want to, that are attached to the socket. This is called a short circuit. So we want to create a short circuit around the light bulb. To do that in here, I just build a little loop that goes around the light bulb. And if you see what happens is the electrons are no longer going through the light bulb, so they're not being slowed down by the light bulb, which is a resistor. They go around the light bulb and go really fast. That causes a lot of friction from these electrons going so fast, which can start fires at various points, especially in the battery. So this is an unsafe situation. A short circuit is a path around the load, which is a resistor, which allows the electrons to go too fast for this circuit, and we could start fires. The circuit is overloaded. So then you're going to answer those conclusion questions. Where are the electrons going? They're not going through the light bulb anymore. They're going on that other path. There can be a fire. So a fuse, what a fuse would do, I'm going to open this up. I'm going to put a switch over here. This is what we did with the balloon on Wednesday. And then I'm going to put a fuse in here. Okay, so when the light bulb is on, because you notice the electrons aren't going through this part of the path because it has a hole in it, so they can't. As the electrons go through the light bulb, everything is fine. The electrons are going nice and slow. If I close this switch, the electrons are now going to go around the load and go too fast. And you see the fuse breaks open. Fuses are put into circuits so that when the circuit gets overloaded, they will break. They break on purpose. They're made of metals that when they heat up, they will break. So they break on purpose so that when the electrons are going too fast, the system will get opened up, which will stop the flow of electrons, which will stop the overheating, which will keep everything safe. You can look up a fuse on the internet. Okay, so let's kind of start fresh. Oh, maybe not. I'll just take some of these system parts out. This is coming out. This is coming out. 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 Get the fuse out. Connect this here. Okay, it's asking us, so we have one loop, and it's asking you to make a prediction. What do you think will happen if I add another light bulb into this same loop? So I'm on number 6. No, I'm on number 5. Okay, so number 5, you're going to make a prediction. Number 6, we're going to actually do it, and you're going to write down what happened. So I'm going to open up the switch. I'm going to put in a light bulb here by cutting this. And then I'm going to close. So this is when you're going to answer number 6. What actually happened? Well, we did something wrong because nothing is lighting up. What did I do wrong? Maybe it doesn't like, you want the wire there. The wire there, and then we can close this. What is going on? Let me play with it a little bit without you guys. Okay, here we go. I got it to work. There's our 2 light bulbs in what's called a series circuit. Like the World Series, we have one game after another, series circuit, one light bulb or one load after another on one circle. Okay? We notice that the light bulbs are a little bit dimmer. That's what you should be writing down for number 6. The reason is the electrons have to go through this light bulb, then they have to go through this light. They lose a little bit of their power because they go through one and then the other. How electrons actually come out of the battery is they're pushed out on this side and pulled back in on this side. If there's one light bulb in the way of that pushing and pulling, then it slows them down. Okay, and then it says to add another light bulb in, so we're going to do that. Over here. And you can see it gets even dimmer. I think for this one, you should be pausing every once in a while and writing your answers down. For number we've gone all the way through number 10 here. I'm going to switch this over to this symbol, and again, you can, and we'll find, where's our switch? Open the switch to this. You guys can take a screenshot of this. This is for number 10. If you want to, you can put in what we just built for number 10. Next, it's asking you to predict what would happen if we unscrewed one of these light bulbs. So if I can't really do that in here. I can't just unscrew the light bulb. So I'm going to show you a video of this over here.
Unscrewing it. Okay, so I'm going to turn it on.
So we've got our
They're both on. They're both dimmer than when we had just one on there. And that reason is because there's only one path for the electrons to flow on. And these are both resistors. It's hard for the electrons to go through the light bulbs. They're also called loads because they're using the electrons. So each one of these light bulbs is a little dimmer than if we had just one of them on here, because they're sharing the power of the electrons. They're all on the same path. So make your prediction right now, and then I'm going to undo one of the light bulbs, and you'll see what happens.
So your prediction is number 11.
People usually predict either that this one's going to get brighter, or that they're both going to go out. You take this one out, and they both go out. And maybe you've seen something where you have a whole bunch of light bulbs on one string, and when one goes out, they all go out.
Christmas lights.
This is often a frustration that we have in our house around December when we're trying to put up the Christmas lights. And we can't figure out why the whole string doesn't work. We have to go through and check every single bulb with a good bulb to make sure to see which one is broken, because that's usually the culprit. One is broken, and so they...
Okay, so you should be able to answer number 12 now. Okay, I'm on to number 13. Okay, so number 13 wants us to remove some of these light bulbs and stuff. I might just start again. So we're going to build a simple circuit again. We're going to build wire, switch, light bulb, back to the battery. And if I close this, it'll start. Okay, so number 13. But now it wants us to add another path, another circuit here around the light bulb. Put a light bulb in there. So this one has its own loop for the light bulb. And I'm going to open the switch. Number 13 wants you to make a prediction. What's going to happen to those two light bulbs when I close the switch? So you make a prediction, pause if you need to, and then I'm going to close this, and then you're going to write down what happens for 14. So 14, you see, this time they don't get dimmer. When they're each on their own loop, they stay just as bright as if there was one. And that's because the electrons don't have to go through this first light bulb to get to the second one. They have their own path back to the battery around the light bulb. Okay, and then it wants us to add a third light bulb onto there. So we say that they're parallel to each other. And we could set them up so that they actually look like they're parallel, but they each have their own loop. And you see the third one is just as bright as well. So I'm going to switch this over to the drawing, and you can copy and paste that into the places where it asks for drawings of the circuit. They each have their own loop. I guess you could do 15, 16, 17. And then I'm going to show you a video that's going to help you with number 19. Okay? 19 says, what would happen if we took, 18. What would happen, predict what would happen if we removed one of the light bulbs. Okay, so I'm going to show you, I made another video for that. This is in parallel, where every bulb has its own loop. We're going to check out what happens.
Around this way. You can go around that opening. And I want to let you know, when I took this light bulb out, it's very hot. And what do you think will happen if we take one light bulb out this time? Last time in a series circuit, the light bulb, when I took one light bulb out, they all went out. Okay, so here I'm going to take this one.
Make your prediction
I'm
first.
going to take this one out.
Now we're doing 19.
You're going to see that nothing happens. The dimness doesn't, the brightness doesn't change, and it stays on. That's because even though this circuit right here, this part of the path is broken and open right now, the electrons can still flow with a complete circuit all the way around this way. They can go around that opening. And I want to let you know, when I took this light bulb out, it's very hot. That happens because as those electrons are flowing through the wires, all the wires, the alligator clips are pretty hot. There's a lot of friction in there, just like friction with your hand, you create heat. Heat is not our desired outcome here, so we call that wasted energy. It's energy that's being converted to something else and it's wasted. That's inefficient. So new light bulbs are being created, LEDs and things like that, that have less wasted energy to heat. It's a form of energy that we don't want, heat, so it's waste. So any light bulb that can do the same amount of light without all that wasted heat is better or more efficient.
Okay, so let's go back to the phet and finish this up. Okay, so we did 19. The examples of a series circuit would be the Christmas lights, where you have one goes out, they all go out, and 21, the example of parallel would be anything else. Hopefully that little video helped you with that assignment.